Picture this. It's July 10th, 1940. The date is burned into the memory of every pilot who would live to tell the story. The sun is climbing over the English Channel, painting the sky in shades of pink and orange. And somewhere in that same sky, death is approaching at over 300 miles per hour. Flight Lieutenant James Brindley Nicholson is strapped into the cockpit of his Spitfire, call sign Yellow 1, and he's about to fly directly into history, though he doesn't know it yet. His hands grip the control stick, practiced and steady. Behind him, the Rolls-Royce Merlin engine roars with 1,030 horsepower of pure British engineering. His visibility ahead is clear, sharp, and perfect. In exactly 7 minutes, that clarity will matter more than any gun, any cannon, or any prayer he might whisper into his oxygen mask. Nicholson isn't alone in the sky that morning. 70 kilometers away, German Messerschmitt Bf-109s are screaming across the channel in formation, carrying death in their wings. This day would become known as the opening of the Battle of Britain, the moment when the skies above England became a roaring, violent arena where the fate of a nation would be decided. But here's what most people don't know. Thousands of British pilots were about to die fighting an enemy that wasn't just the Luftwaffe. They were fighting a material crisis so severe that the Air Ministry had to make desperate, almost inconceivable decisions to keep their aircraft flying. And one of those decisions would trace directly back to the greenhouse gardens of England, to 16,000 melted window panes, and to a company called Triplex that would become the unsung hero of the British Air War. The irony of what I'm about to tell you is almost brutal. While Hitler's Germany was spending millions on advanced aircraft manufacturing, sourcing specialized materials, and building an air force designed to dominate the world, Britain, desperately fighting for survival, was melting greenhouse glass to protect the men who would defend the nation. It's the kind of story that captures everything about the Second World War. Innovation born from desperation, survival through ingenuity, and the weird, wonderful ways that ordinary industrial processes became extraordinary weapons of war. To understand why Britain was facing a crisis over something as simple as aircraft windscreen glass, we need to step back and see the bigger picture of what was happening in 1940. By the middle of that year, Hitler's military machine had already conquered France. It had swept through Belgium. The British Army had barely escaped across the Channel at Dunkirk, leaving behind mountains of equipment, tanks, and weapons that the nation couldn't replace. Prime Minister Winston Churchill had just given his famous "We shall never surrender" speech on June 4th, delivered with all the gravitas and fury a man could muster when he's staring down the possibility of national extinction. The country was traumatized, exhausted, and running on fumes, literally. Germany now had the French aircraft industry. It had the Czech aircraft industry. It had captured Renault factories, Peugeot workshops, and hundreds of other manufacturing facilities across occupied Europe, and Germany was using all of it. The Luftwaffe was building new fighters almost faster than Britain could shoot them down. Every pilot killed, every aircraft lost, meant the Luftwaffe could replace it. For Britain, every loss was like watching money you couldn't afford to spend disappear into the sea. The government had mobilized the entire industrial base, but there were still shortages everywhere: steel, aluminum, copper, rubber. And among the long list of things Britain was running out of in the summer of 1940 was something nobody had thought much about before the war started: optical glass. The kind of glass used in aircraft windscreens and cockpit canopies isn't ordinary window glass. It has to be optically clear, distortion-free, and incredibly strong. It has to withstand the forces of acceleration and violent maneuvers, the vibration of massive engines, and the extreme cold of flying at altitudes over 20,000 feet. Before the war, most of this specialized optical glass came from Germany, which is to say it was now completely unavailable. Britain had exactly one major manufacturer of proper aircraft glass, and by 1940 they were overwhelmed. The production couldn't keep up with demand. Squadrons of Spitfires and Hurricanes were being built faster than they could get windscreens fitted. It was a bottleneck that threatened to cripple the air defense of the entire nation. This is where we meet a man named Lionel Crescent Creed, a manager at a glass company called Triplex Safety Glass. Triplex wasn't known for aircraft components. It was known for making safety glass, the kind of laminated glass used in automobile windscreens, which had the extraordinary property that when it shattered, it didn't spray sharp, deadly shards across the driver's face. Instead, it would fracture in a web-like pattern while holding together, preventing injury. This was revolutionary technology for cars, and it had saved countless lives on roads across Britain. But in 1940, Creed realized something remarkable. If Triplex could apply the same lamination and molding technology to aircraft windscreens, they could manufacture the optical glass that Britain's RAF desperately needed. The challenge was staggering. Aircraft windscreens aren't flat sheets like a car's windshield. They're curved, molded pieces that need to provide visibility while withstanding extreme pressures. The cockpit of a fighter aircraft is a brutal environment. A pilot sitting at 30,000 feet is exposed to temperatures of -40 degrees Celsius. The pressure differential between the cockpit and the atmosphere outside tries to crush the canopy. Wind forces during high-speed dives and turns create tremendous stresses, and bullets don't stop for industrial inconvenience. A Spitfire's cockpit might take flak from enemy fire, and that glass needs to hold. Traditional optical glass methods couldn't produce these curved windscreens in sufficient quantities. British optical glass makers were already at maximum capacity, and expanding their factories would take months or even years. So Creed and his team at Triplex began experimenting with something nobody had seriously considered before. What if they could source raw glass materials from unconventional places? What if they melted down glass that was already available in Britain but serving a different purpose? Somewhere in those early 1940 meetings, someone had a thought, probably obvious in hindsight but revolutionary at the moment. Britain's greenhouses, the glass structures that had allowed the nation to grow fruits and vegetables for centuries, contained millions upon millions of glass panes. Wartime regulations had already begun restricting greenhouse use anyway. Food production was shifting to essential crops and rationed agriculture. Thousands of gardeners had shuttered their greenhouses for the war effort. The glass was there, it was available, and it could be recycled. The decision was made with the kind of desperate pragmatism that defined wartime Britain. Triplex would launch a national campaign to collect greenhouse glass. They would melt it down, purify it, and mold it into the curved optical windscreens that Spitfires and Hurricanes needed to defend the nation. It sounds simple when you say it quickly, but the logistics of this operation were extraordinary. Imagine coordinating the collection of broken or whole glass panes from thousands of greenhouses scattered across the entire country. Imagine transporting fragile glass across roads damaged by bombing, through cities under air raid, to centralized collection points. Imagine the equipment failures, the transport delays, the countless logistical problems that arise when you're trying to source 16,000 glass panes during an active war. Yet this is what Britain did. The campaign began in 1940, right at the height of the Battle of Britain, right when the country needed aircraft most. Households that had greenhouses were asked to contribute them to the war effort. Gardeners, many of whom had tended their greenhouses for decades, watched as the structures were dismantled and the glass collected. Local councils helped organize the collection. Military units assisted with transport. It's a remarkable detail that tends to get glossed over in histories of the war, but it speaks to the total mobilization that Britain underwent. This wasn't an industrial order from the government. It was a call to sacrifice that reached into the gardens of ordinary people. The 16,000 panes represented something profound. Each pane came from a greenhouse that had fed a family, that had grown tomatoes or cucumbers or flowers during peacetime. Now those panes would protect the men who fought in the sky. There's a connection there, a thread of continuity between civilian gardeners and fighter pilots that captures something essential about the Second World War. This wasn't just a war fought by soldiers and factories. It was a total war that demanded something from every person, in every walk of life. A greenhouse owner who had no combat role to play, who had never fired a weapon, who simply grew vegetables for their own table, suddenly became part of the air defense system of the nation. But here's where the story becomes even more interesting. Triplex didn't just collect the glass, they had to transform it. Raw greenhouse glass isn't the same as optical glass. It contains impurities, it has slight color variations, it's often thicker or thinner than required. The team at Triplex had to develop a process to melt this collected glass under precise conditions, removing impurities and achieving the correct optical properties. They had to cool it properly to avoid internal stresses that would cause the glass to shatter under pressure. Then they had to mold it, bend it while it was soft, form it into the exact curves that a Spitfire or Hurricane windscreen required. This required molds, careful temperature control, and tremendous engineering skill. Leading this technical challenge was a team of engineers whose names have largely been lost to history, which is tragic because what they accomplished was nothing short of remarkable. They created a successful process for taking 16,000 pieces of melted greenhouse glass and transforming them into aircraft-grade optical components. The windscreens they produced were tested extensively. They had to meet RAF specifications, had to be clear enough for pilots to see clearly, had to be strong enough to withstand the stresses of combat flying. And remarkably, they worked. The Triplex windscreens proved to be reliable, durable, and effective. Now let's jump back to July 10th, 1940, and Flight Lieutenant Nicholson in his Spitfire. Somewhere in the tense moments of that morning as he climbed toward the German formations, it's possible, perhaps even probable, that the windscreen protecting his view of the sky came from triplex made from glass collected from British greenhouses. As he pushed his aircraft to its limits, diving at enemy fighters, pulling high-G maneuvers that would test every component of his machine, that curved piece of molded glass kept him sealed inside his cockpit, kept the pressure differential manageable, kept him alive, and it had started as somebody's tomato patch. By the end of the Battle of Britain in October 1940, Triplex had supplied thousands of windscreens to RAF fighters. The production process, once refined, became a model for continued manufacturing throughout the war. What had started as an emergency measure became a standard solution. Other manufacturers picked up the technique. Other sources of recycled glass were identified and used. The principle that Triplex pioneered, taking available materials and transforming them through industrial ingenuity to meet critical wartime needs, became a template for British war production across dozens of industries. The battle itself was brutal. The Luftwaffe lost over 1,700 aircraft during the 4 months of intensive fighting from July to October 1940. The RAF lost roughly 1,000 aircraft. But here's the critical point. Britain could not be invaded if it controlled the air over its own territory. Every RAF fighter that stayed in the sky represented a potential German bomber shot down, a German invasion fleet turned back, a German soldier who would never set foot on British soil. The fighters themselves were technological marvels, but they were only as effective as the men who flew them. And those men needed to see clearly through their windscreens. They needed equipment that worked reliably under extreme conditions. The triplex windscreens never made headlines. No RAF pilot received a medal for flying through greenhouse glass. No war correspondent filed a dramatic story about recycled panes. But this innovation, born from desperation, and powered by ordinary British citizens contributing their gardens to the war effort, became part of the infrastructure that allowed Britain to survive when survival seemed impossible. It's the kind of story that shows how victory in the Second World War wasn't achieved through spectacular moments alone, but through countless small innovations, material solutions, and the mobilization of ordinary resources in extraordinary ways. By 1941, as the triplex windscreen production continued and proved its worth, the process had become so established that the company began exploring other applications. Could they mold aircraft gun turret windows? Could they produce protective glass for bombing runs and other combat situations? The answer to these questions expanded Triplex's role in the war effort beyond windscreens. The company that had started as a car glass manufacturer had become crucial to aircraft production, and the solution that had begun with GreenhousePanes ultimately influenced multiple elements of RAF equipment and capability. What's remarkable is that this all happened because someone in a triplex meeting room had the imagination to see possibility where others saw scarcity. Lionel Creed and his team could have declared that optical glass was unavailable, that windscreens couldn't be produced in quantity, that the problem was beyond solving. Instead, they looked at what was available and asked how to transform it. That's the spirit that permeated British production during the war years. That's how a nation with fewer resources than its enemies found ways to match and eventually exceed enemy production. It wasn't magic. It was engineering, creativity, coordination, and the willingness to take unconventional solutions seriously. The story of triplex windscreens illustrates something that often gets lost when we talk about World War II. We tend to focus on the grand strategies, the battles, the leaders, the military innovations. We talk about radar, which gave Britain the intelligence advantage to win the Battle of Britain. We talk about the Spitfire and Hurricane designs, which proved they could match German fighters. We talk about pilot training and RAF organization, but we rarely talk about the glass. We don't mention the greenhouses, and that's a shame because the complete story of how Britain survived includes these details. Victory in 1940 was no less dependent on recycled greenhouse glass than it was on radar stations or superior pilots. Consider the timeline from another angle. Between June and October 1940, the British aircraft industry needed to produce and deliver thousands of windscreens. Traditional production methods couldn't support this demand. The supply chain was broken. Materials were unavailable. Any one of these bottlenecks could have reduced RAF fighter availability by critical percentages. Lower availability means fewer pilots in the sky. Fewer pilots means fewer German bombers shot down. Fewer bombers shot down could mean successful attacks on British airfields. Successful airfield attacks could mean German air superiority. German air superiority could mean invasion becomes possible. The chain of consequence reaches all the way from a greenhouse pane to the potential invasion of Britain. This is how wars work at the material level. After the war ended, Triplex's contribution was quietly acknowledged. The company continued to produce glass products and became one of Britain's premier glass manufacturers for decades. But the specific story of the greenhouse campaign and the 16,000 melted panes gradually faded into obscurity. The men who built the Spitfires and Hurricanes received recognition. The pilots who flew them became heroes, many remembered by name. But the engineers at Triplex, the logistics coordinators who organized the collection campaigns, the ordinary citizens who donated their greenhouses, they became footnotes in the larger narrative of the war. Yet their contribution was real and measurable. Every RAF pilot who flew through the Battle of Britain in an aircraft with a triplex windscreen made from melted greenhouse glass was benefiting from this innovation. When Spitfires escorted bombers over occupied Europe in 1941 and 1942, they were looking out through these windows. When RAF fighters intercepted German night bombers in the dark, the pilots depended on clear visibility through optical glass that had been a garden structure months earlier. The connection might seem strange to modern sensibilities, but it was direct and essential. The legacy of this story extends beyond the war itself. Triplex went on to develop new glass technologies and remained an important manufacturer throughout the second half of the 20th century. More importantly, the principle of material innovation under constraint became part of industrial DNA in Britain and across the Allied nations. The idea that you could solve critical problems by applying engineering creativity to available resources became embedded in how manufacturers approached problems. It's a principle that remains relevant today, whether we're talking about sustainable manufacturing, recycling initiatives, or industrial innovation. If you're interested in the smaller stories within World War II, the ones that don't always make it into the major histories but that reveal how the war was actually won, this is the kind of narrative that deserves more attention. The GreenhousePanes are a perfect example because they're unusual enough to be memorable but perfectly illustrative of how the war actually worked. Someone saw a problem, someone else saw available resources, and through coordination, engineering skill, and determination, they created a solution that mattered. Flight Lieutenant Nicholson survived the Battle of Britain, incidentally. He went on to become the only Royal Air Force pilot to receive the Victoria Cross for his actions during the battle. That medal was awarded for bravery, for his actions in combat, for his skill as a pilot. But it was awarded while he was looking through a windscreen made from greenhouse glass, protected by the innovation that Triplex had developed, supplied by materials that ordinary British citizens had contributed to the war effort. He probably never knew the origin of the glass that protected him. Most pilots didn't, but the story is there, connecting the gardens of Britain to the skies where victory was won. This is what the Second World War really was in many ways, a total mobilization of industrial capacity, human ingenuity, and national will. It was fought in factories and gardens as much as it was fought in the sky. And Britain's survival depended on countless innovations, each one solving a critical problem, each one representing the creativity and determination of the people who worked on them. The triplex windscreens stand as a testament to that spirit. The next time you look at old footage of Spitfires in combat, remember that the pilot looking out through the windscreen might well be seeing the world through glass that once protected vegetables in a wartime garden. That connection between civilian contribution and military necessity is the story of Britain in 1940. What makes this story particularly fascinating from a modern perspective is how it challenges our assumptions about how wars are won. We think of major industrial powers with vast resources and established supply chains having advantages, and of course they do. But we often underestimate the power of rapid innovation under constraint. Germany in 1940 had more resources and more manufacturing capacity than Britain. Germany had access to conquered territories and could draw on European industrial output, yet it was Britain that found the solution to the windscreen problem through creative recycling and innovation. It was Britain that adapted, improvised, and discovered new ways to produce critical materials. In the months following the Battle of Britain, as triplex windscreen production ramped up and proved its reliability, RAF fighter availability increased. The data is clear. More aircraft in service meant more sorties flown, more bombers intercepted, more lives protected on the ground. The reduction in German air attacks by late 1940 and into 1941 was partly due to Luftwaffe losses and exhaustion, but it was also due to RAF aircraft availability and effectiveness. Triplex's contribution was embedded in those statistics. Those 16,000 recycled greenhouse panes represented perhaps not the largest factor in British victory, but certainly a measurable one. And they represented something else, proof that ordinary people contributing ordinary resources in extraordinary ways could influence the course of the war. By 1942, the recycled glass windscreen program had become so successful and so integrated into RAF production that the demand for new greenhouse glass collections actually decreased increased. The initial 16,000 panes had been sufficient to establish production processes and train engineers. Once those processes were perfected, manufacturers could plan longer-term production using industrial glass supplies that had been allocated to the program. The emergency aspect of the campaign had passed, replaced by established production channels. But those early months in 1940 were crucial, and the initiative had proven invaluable. Today, we might look at this story and see lessons for our own times. In an era where supply chain resilience and adapting to material constraints are becoming increasingly important, the Triplex example offers instruction. The company didn't wait for perfect solutions or ideal circumstances. They used what was available, applied engineering expertise, and solved a critical problem. They demonstrated that innovation doesn't require unlimited resources. Sometimes it requires imagination, determination, and the willingness to try unconventional approaches. The human stories behind this industrial innovation remain largely untold. We don't know the names of most of the Triplex engineers who worked on the molding process. We don't have detailed records of every gardener who donated their greenhouse glass, though some local histories have preserved accounts of the campaigns in their areas. We don't have personal testimonies from the RAF pilots who flew with Triplex windscreens, though some may still exist in archive collections. These are the stories that get lost when we focus on the grand narrative of the war. They're forgotten even as their physical contributions survive, in historical aircraft preserved in museums, in technical documents filed away in archives, in the engineering principles that remained in use long after the war ended. If this story interests you and you want to learn more about the lesser-known innovations that made World War II possible, there are some excellent resources available. The Imperial War Museum in London has extensive materials on industrial production and civilian contribution to the war effort, including information about materials recycling programs. The RAF Museum has detailed records of aircraft production and maintenance. Local historical societies across Britain have documented collection campaigns and community contributions to the war effort. And there are specialist histories of British glass manufacturing that include chapters on the wartime innovations that companies like Triplex pioneered. What we're looking at with the Triplex windscreens is a complete snapshot of how the Second World War was actually won. You have a clear material problem. Aircraft windscreens are needed but can't be sourced through conventional channels. You have a company willing to innovate. Triplex saw an opportunity and pursued it. You have a government that supported unconventional solutions. The Air Ministry agreed to specifications for recycled glass windscreens. You have a civilian population willing to sacrifice. Gardeners gave up their greenhouses. And you have engineers and workers who executed the plan. Triplex's technical team created a working manufacturing process. All of these elements had to align for the solution to work. In the end, the 16,000 melted greenhouse panes represent something beyond their material quantity. They represent the total mobilization of a nation facing existential threat. They represent the resourcefulness and adaptability that allowed Britain, with fewer resources than Germany, to match and eventually surpass German production in the critical field of fighter aircraft. They represent the often invisible contributions of ordinary people to extraordinary historical events. And they remind us that history is not made only by the famous and celebrated, but by the engineers, workers, and citizens who solve problems, meet challenges, and contribute their resources to shared purposes. So the next time you see an image of a Spitfire banking hard into a turn, its elliptical wings catching the sun, the pilot inside focused on the enemy ahead, remember those greenhouses. Remember the people who maintained them, who gave them up for the war effort. Remember the Triplex engineers who figured out how to transform that glass into something that would protect those pilots. Remember that victory in the Second World War was built on countless small innovations, material solutions, and the collective effort of millions of people at every level of society. The story of the Triplex windscreens is just one small chapter in that vast narrative, but it's a chapter that deserves to be remembered and told. If you found this story compelling and want to see more videos exploring the hidden histories and lesser-known innovations of World War II, please consider subscribing to the channel. We dive deep into these stories that shaped the war but rarely make it into the mainstream histories. Thank you for watching, and we'll see you next time.